Hi there, and welcome to How to Win at Chemistry, lecture number 1. Today we'll be doing an example of an empirical formula problem. Usually in these types of problems, you'll be given the mass percent for each element in the compound, and you'll be asked to give the empirical formula. Let's first review some of the terms we'll be using. First up is mass percent, which is the ratio of one element's mass to the mass of the entire compound. The easiest way to think of mass percent is to imagine that you have 100 grams of the compound in front of you. Let's also say, for example, that compound is 10% lithium and 90% oxygen. That means that you would have 10 grams of lithium and 90 grams of oxygen in front of you. The other relevant term is empirical formula. The empirical formula is just a comparison of how many moles of each element are present in the compound, but reduced to lowest terms. For example, if you had the compound C2H6, you could divide each number by 2 to reach lowest terms. This leaves you with an empirical formula of CH3. So if you think about it, since your mass percent refers to mass, and your empirical formula refers to moles, a problem that asks you to convert mass percent to empirical formula is just a gram to mole conversion with a couple of extra steps. I'll summarize the process for you before we begin. Step 1 is to change your mass percent to grams by imagining that you have 100 grams of compound. Step 2 is to convert your grams to moles by dividing by the molar mass of each atom. Finally, step 3 is to reduce your moles to lowest terms by dividing by your lowest term. For some problems, your terms for step 3 will end up as decimals, which will require a fourth step. But this video will cover an easier example that only requires 3 steps. Let's begin our problem. Here's our question. If a compound has 38.71% carbon, 9.68% hydrogen, and 51.61% oxygen, what is the empirical formula? Step 1 is to imagine that we have 100 grams of compound. For carbon, what is 38.71% of 100 grams? If you said 38.71 grams, you win a cookie. Similarly, you should end up with 9.68 grams of hydrogen and 51.61 grams of oxygen. Step 2 is to find how many moles of each atom we have. To find moles, we simply divide the masses we just found by the molar mass of carbon, oxygen, and hydrogen. If you've practiced conversions a lot, you may have them memorized, but don't worry if you don't. All of our molar masses may be found on the periodic table, and we can look one up right now. Let's just switch over to our internet browser. First, we'll type periodic table into Google and press enter. You'll have a ton of results, but remember that not all periodic tables are created equal. Some of them won't even have molar masses on them, and those won't help us here. Let's click Images right under the search bar and try to find a suitable one. Well, we have hundreds of tables to choose from, but let's select the first table in the upper left-hand corner to start. This one looks like it has plenty of information, but it's kind of hard to read. Let's click View Image in the gray zone on the right side to see if we can get a better view. It's still a bit difficult to read, but notice we now have a magnifying glass icon which allows us to zoom in. Just click once, and yes, that's much easier to read. Our molar masses are the numbers at the bottom of each box. Now you'll find carbon and oxygen on the second row of the table near the right side. We see that carbon has a molar mass of about 12 and oxygen's is about 16. You can include the decimal places if you like, but I'll be leaving them out for simplicity's sake. If we scroll to the left, we'll see hydrogen in the upper left corner, with a molar mass of about 1. With that in mind, let's return to our problem. Let's divide our carbon mass by 12, our oxygen mass by 16, and our hydrogen mass by 1. If we punch these into a calculator for carbon, we'll get that 38.71 over 12 is 3.226. For oxygen, 51.61 over 16 gives us 3.226 again, while hydrogen's 9.68 grams over 1 just gives us 9.68. Now all that's left is to reduce our moles to lowest terms for step 3. We'll usually do this by dividing by the lowest number of moles. We have 3.226 moles of carbon and oxygen, and hydrogen is definitely higher at 9.68. So let's divide them all by 3.226. Carbon and oxygen will obviously give us a result of 1. But if we divide our 9.68 moles of hydrogen by 3.226, we get 3.00062. That's so close to 3 that we may as well just call it 3. So our final answer has 1 carbon, 3 hydrogen, and 1 oxygen. This means our empirical formula is CH3O, because chemists usually don't like to write 1s unless we have to. And there you have it. Now, there are plenty of complicated variations on this problem, but that's a story for another time. For today, thank you for watching, and remember to keep winning at chemistry.